Today we're going to be continuing our Sudoku tutorial series. So I'm going to open with a tutorial this time on arrows. The way this works is that I pick one every Wednesday is how I'm going to do this. I'm going to pick one sort of standard variant, and I'm going to do some number of puzzles with that variant. Some of them will be easier, then one will sort of be medium, and I'll sort of try and go over what I think the key things you need to know are for that mechanic. So last week I did Kropke. That video has gotten snipped. Tristan can put a link to that as well in the chat. So you can also see last week's intro to Kropke if you like. This week we're doing arrows, and as it turns out, there is no shortage of vanilla arrow puzzles. And by coincidence, or perhaps because people knew the theme was coming, actually even the puzzle that was voted on by the most of the supporters to do today is also a vanilla arrow puzzle. So we're going to do vanilla arrow puzzles by all kinds of setters today. So you'll get to see a whole bunch of cool stuff of that sort. With that, I'm going to start, and so usually when I'm looking for easy puzzles that highlight mechanics, the thing I go to are the gas puzzles. So there's a gas puzzle every day that is posted over on the Cracking the Cryptic Discord. If you're not on the Cracking the Cryptic Discord, I really recommend it. These are meant to be doable in 5 to 10 minutes, depending on how quick you are. I'm not going to speed run these. I'm going to try and go slowly through these and explain the deductions so that you can sort of follow along and get these sorts of things if you've not seen these things before. So in this case, I could not find too many pure arrow gas puzzles that did the thing I wanted to highlight. So I actually have gone and grabbed, and people have recommended to me, thanks by the way, people have recommended to me good tutorial puzzles that are not officially gas puzzles, but that highlight various elements of Arrow Sudoku. By the way, I said last time, and I will say again, if you have puzzles, or if you make puzzles that you think are in the 2-star difficulty range that really highlight a particular vanilla constraint, please let me know. I didn't say last time, but I should have. If you know of other puzzles by other setters that do a really good job of highlighting a particular constraint, then you should let me know about that too. So in particular, actually, I had said last time I was probably going to do Kurobon's puzzle as an example, and Kurobon said, hey, actually, I think the perfect 2-star puzzle to highlight arrow stuff is this puzzle by Playmaker that we'll do later. So I'm going to do that puzzle. But people have sent me lots of other arrow puzzles. So I'm going to have plenty of things to do arrow wise. And I will, of course, still do Kurobon's arrow puzzle later. All right. So how do arrows work? The way that arrows work is that the digit that goes in the circle is the sum of the 3 digits, or however many digits, lie along this line. So for example, this could be 2. For example, I could turn my keypad on. So for example, this 7 could be 2, 1, 4, because 2 plus 1 plus 4 is 7. Right. Now, I chose this puzzle to start because I think this puzzle really highlights what I think is the most important part of arrows, which is length 3 arrows. So I prepared a graphic. So here is all of the length 3 arrows. And so this looks like a lot, but it's actually not that much. If you do many arrow puzzles, you will not have to do them for very long before you sort of internalize these. So the first thing to note is this is every possible length 3 arrow where all 3 cells on the arrow see each other. So if I had an arrow that went, say, like this, went like that, then this arrow would not apply to the thing I'm saying for the reason that arrows can have repeats. So for example, that was probably a terrible example. But what I'm talking about here are arrows where all 3 digits on the arrow see each other. So this arrow, for example. And so this is all of the ways to fill them in. Derektionary points out helpfully that there's too many 1s in column 1, which I will acknowledge. So you'll see that whenever you have 3 cells on an arrow that all see each other, the minimum possible value they can go in the circle is a 6. And so that means that quite often, and if you watch Cracking the Cryptic very often, you'll see this all the time, the first thing you do in an arrow puzzle is fill 6, 7, 8, 9 in a bunch of arrow circles. Now, of course, in this puzzle, all of the arrow circles have been filled in. But that means that this puzzle is going to do a very good job of letting us sort of use this list and sort of see how this works. So, for example, a 6 arrow in 3 is always 1, 2, 3. A 7 arrow in 3 is 1, 2, 4. 8, there are 2 flavors. There's 1, 2, 5 and 1, 3, 4. But this box has a 3. And so this is 1, 2, 5. 7 is always 1, 2, 4. Again, 8, there are 2 flavors. There's 1, 2, 5 and 1, 3, 4, but there's a 5 in the box, so this is 1, 3, 4. This 8, again, there are 2 flavors, but there's a 4 in the box, so this one's the 1, 2, 5. This one is 1, 2, 3. And then 9 is the one where there are 3 flavors. And a thing that's going to come up an awful lot as we do a bunch of arrow puzzles is that the 9 arrow is the only one where there's a flavor where none of the digits are 1. Namely, it's possible that a length 3 9 arrow is 2, 3, 4. Now, as it happens, this 9 arrow can't be 2, 3, 4, and it can't be 1, 3, 5 either. So in fact, this is 1, 2, 6. But it will often come up that you'll be thinking about 1s, and we'll see this later, where it will turn out that, yes, we get a 1 on this arrow or whatever. All right, so in this particular puzzle, we've just done a bunch of examples of sort of how length 3 arrows are forced, and now the rest of this is going to be Sudoku, because if I look across here, I've got a 1 and a 3 looking at this cell, so this cell's a 2. And now I've got a 1 and a 2 looking at this cell, so this cell's a 4. This cell now has a 4 and a 2 looking at it, so it's a 1, and that's a 2. This has a 1 and a 2 looking at it, so it's a 3, and therefore this is a 1. This cell... Sorry, I was looking for another cell. Maybe there's not an easy... there probably is another easy gimme. Let's see. Where is... what's the next gimme here? I was trying to do this as slickly as possible, which we don't have to do, of course. We can just do things like fill in this column. This column's got 1, 2, 3, 4, 5 already, so it needs a 6, 7, and a 9. That cell's not a 7, that cell's not a 6, that cell's not a 9. And this column needs, it's got a 1, 2, 3, 4, 5, 6, it needs a 7, 8, 9. Those aren't 8, so this is 8. This one's not 9 either, so it's a 7 and a 9. 7 looks over there and goes and makes that a 6, that a 9 and a 7. And so these are complete with cheat sheet, indeed. 1, 2, 3. We need a 4 in here, and we've got a 5, and we need a 6. Again, when I'm center marking anything, just in case you haven't seen this before, what I'm doing is I'm marking every possible digit that can go in these cells. So this has to be, these digits have to be from 1, 2, 5. These have to be from 4, 6. I'll also use corner marks later, and I'll mention exactly how that works. But in particular, these 3 cells are a 1, a 2, and a 4. So this can't be a 4, because it has a 1, a 2, and a 4 looking at it. In particular, it has a 4 looking at it. So this digit has to be a 6, which now means that digit has to be a 4. Now I ask where 4 goes in row 2. We've got 4s here and a 4 here looking over, ruling 4 out of all of these cells. So that's where the 4 goes in this box. These 2 digits are a 7 and a 9, just to finish that off. Let's see. That's right. Simon saying how scary Tallcat was I do find Tallcat quite a scary setter. That was quite nice. That's right. I'm not supposed to be chatting. Tristan will chide me later. Let's see. We can fill in these digits as to what's left in this box. This 4 looks up here. That's not a 4. That's not a 1. That 1 looks down there. That's not a 1. where does 6 go in this box? Let's do that. 6 in this box is here. So we can fill in that. Let's see. So now this digit's a gimme. Chat can chat all they want. I'm just supposed to try and keep it so that people can watch in the VOD. I will still talk a bit, but I'm basically just trying to make it good for someone to watch later. So 3 not here. That makes this a 1, 2, 5 triple. And so that means we've got the 1, the 2, the 3, and the 4, and the 5 in the column, and the 6. So these are from 7, 8, 9. That one's not a 7. Let's see. Alrighty. Let us continue, which we will do by looking at, let's see, let's look at row 9. We've got 1, 2, 3, 4, 5, 6. We need a 7 and a 9 down here. And that 7 tells me that's the 9 and that's the 7. This is the 2. I did not fill that in correctly. This is the 2. That 2 looks over here, makes this a 1, 5 pair, makes that a 2. That 2 makes that a 1, which then makes that a 5 and a 1. Means these aren't 1. We've got 1 looking over here, so this isn't 1. Neither of these is 4, in fact, so that's the 4, the 3, and the 1. That 1 means that's not a 1. In fact, this 2 means these aren't 2, so that one is 2. That 1 looks over means that's a 5 and a 1. That 2 looks over means that's a 3 and a 2. These 2 cells are a, let's see, we've got 1, 2, 3, 4. We need a 6 and a 5? Is it a 6 and a 5? Yeah, we need a 6 and a 5. So the 5 goes there, the 6 goes there, owing to that 5. That 6 looks down, gives me a 2 down here. These aren't 2. These are from, let's see, we've got 1, 2, 3. We need a 4, which has to go there. We've got a 5, 6, 7, and we need an 8, which has to go there. So those are not 8. These digits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 5, and 7. This one's not a 3 or a 7, so it's a 5. So these aren't 5. They are 3 or 7. Which you'd think would be resolved, but if it is, I don't see it yet. This cell is not 1, 2, or 4. So it is a 1. Sorry, it's not 2 or 4, so it is a 1. That's a 2. That's a 4. 1 looks down and makes that a 6 and that a 1. This is not a 6 anymore, so this cell is an 8 or a 9. This, let's see, we've got a 6 here already. Let's see, this column, we've got 1, 2. We need a 3, which we know where it goes. The 3 goes there. We've got a 4, a 5, a 6, a 7, and we need an 8, which has to go there. Here, we've got, let's see, we've got 1, 2, 3, 4. We need a 5, 6. We've got 7, 8. We need a 9. So let's see, this is not 5 or 6, so it is 9. These aren't 9. They are from 5 and 6. 1, 2, let's see. Okay, so I need a 3 in here, and then an 8 and a 9. This one's not a 9, I know. This one's not an 8, I know. It's all beautifully worthless. Okay, this row, I need a 7, 9. Oops, I don't need a 7, 9 here, because there's a 9 in the row already. So that makes that a 7, that an 8, that a 9, and that a 6. And that 9 makes that an 8, a 3, and a 9. 3 makes that a 7 and a 3. And so we've got here 1, 2, 3. We need a 4 here. Let's see, 8 and 9 look at this cell, meaning that's a 7. This has to be a 5 or a 6 for the row, but it's not the 6, so it's the 5, that's the 6, that's the 5. this has to be an 8 or 9 for the box, but by the column, it is not an 8, so that's a 9 and an 8. The 9 looks up, makes that a 7 and a 9. And then we are done. Alrighty. So that's a sort of demonstration of the power of knowing the possibilities for a 3-cell arrow. And we're going to see, as we go on, increasingly sophisticated ways of using this knowledge of what the 3-cell arrows are. I really liked the resolution of this. It might have just been that I was slow, but I liked the resolution of this 6, 7, 8, 9 in the middle. It ended up sort of unwinding everything around it. Okay. In contrast to the previous puzzle, this one has no 3-cell arrows. So we're going to get to talk about other things in this. And a thing that shows up a lot in Sudoku puzzles of many, many genres is paying attention to the digit 9. And the key observation about the digit 9 is that the digit 9 can never go on an arrow. And so when I ask where 9 goes in box 9 here, for example, one of the things I can do is say, okay, well, it's not going on these arrows. 9 is not 7, it's not 8, and it's not in the column with a 9. So the 9 actually has to go there. Okay, and so we get that. Now, there are some pieces of logic that you can pull from other genres. So in Killer, XV, and whatnot, it shows up that there's actually only 2 ways to add 2 numbers to get 5, which are 2 and 3 or 1 and 4. And because of this 3 here, I know which this is. Namely, you can still think about what the possibilities are for a 2-cell arrow, even if I think it's probably more a distraction than an aid if I threw them all up over my face over there. So now we can fill in the rest of this box, and so we'll get 2, 6, 7, 8. And now here's a really useful time to ask yourself the question, how are these numbers adding to 9? Well, a 6 would need a 3, and an 8 would need a 1, and both of those are gone. So in fact, this arrow we can actually figure out as 2, 7, and so these are a 6, 8 pair. And so we're sort of off to the races in terms of that right away. If you know these offhand, then that can be helpful. But even if you don't know the possibilities offhand for an arrow, if it's a 2-cell arrow, you can just write them in and look, and then you can kick stuff out pretty quickly. So speaking of looking at ways to make things, how are we making this 8? Well, could there be a 1 on this arrow? No, because then I would need a 7. Could there be a 2 on this arrow? No, because then there would need to be a 6. Could there be a 3 on this arrow? Well, yes, if it was 3, 5. Could there be a 4? Well, no, because then I'd need 4 and 4. And I can't put 2 4s in a Sudoku box. But now, actually, if I start going higher than 4, then that's not going to work. Because then I'm going to start needing the 1, 2, 3s again. So in fact, actually, if you look, this arrow has to be a 3, 5 pair. And so now what's this 6 arrow? Well, could it have a 1? No, it can't, because if this had a 1 on it, it would need to be 1, 5, and there's a 5 on this arrow, so it's not that. So the only other option is 2, 4, which has to be what this arrow is. Again, if I go up 1 more, I'm at 3, 3, and then I'm going down and looking at the combinations I've already written down the other direction. All right, and so now I ask what digit is missing in this box. It's a 1, and so we get to fill in a 1 there. You can do a similar thing here. For example, if we just looked at what the combinations for 6 are, there are only 2 ways to make 6. There are 1, 5, and 2, 4. This one can't be 2, 4 because there's a 2 in the box, or more sophisticatedly because there's a 2, 4 pair looking at this cell. But both of those ways tell you that this is a 1, 5, and in fact we know the order. It's a 5 here and a 1 here. And so, again, we can play the same game with this 7 arrow. Is there a 1 on it? No. Is there a 2 on it? No. What about a 3? Well, then that would be 3, 4. But I need a 1, 2, or 3 on it, and I can't have a 1 or a 2. So this has to be 3, 4. And there's already a 3 in row 9. So this is a 4 and a 3. And so I can then go ahead and fill out these cells. 1, 2, 3, 4, 5, 6, 7. These are an 8, 9 pair. And actually, that's even resolved by the 8 down here. So that's a 9 and an 8. Okay, so we're off to a pretty good start here. So here's an arrangement I want to highlight that comes up a lot. Namely, these two 6 arrows that are looking at each other. And so the point is, there's 2 ways to make 6. There's 1, 5, and 2, 4. But whenever you have an arrow vertically that looks at one horizontally, like this, of the same flavor, they can't be the same, because this can't be a 1, 5 arrow because it's got a 1, 5 looking at it. And so every time, and in fact, actually, the same pattern was true over here, every time you have a horizontal arrow of one of these that's looking at a vertical one, they have to be different. And so this one has to be the not 1, 5 one. This one has to be the 2, 4 one. This is, again, one of those things that shows up in Sudoku of all kinds. It shows up in Killer Sudoku. It shows up in XV Sudoku. It shows up at a bunch of different places. But it's useful to pay attention when you have sort of like 2 of the same thing looking at each other in that arrangement. Okay, so this 2 looks up and gives me the 4 and the 2 there. Like that. And so now this 9 arrow is looking sus. So it could have an 8 on it if it's 1, 8. Can't have a 2 on it. It can't have a 3 on it either, because that would need a 6. And it can't have a 4 on it, because that would require a 4. And it has to have a number that's less than 9/2 on it. So it has to have a 1, 2, 3, or 4. And we've just shown the only one of 1, 2, 3, and 4 it can have on it is a 1. This 1, 4 pair looks down here to tell us that this isn't the 1. So that is an 8 and a 1. And so we have that now filled in. So we have all of that. This 2, 7, by the way, I am looking, the 2, 7 looks down here and makes that a 4 and a 2. While we're looking at Sudoku stuff. Let's see. Where else can we look? I think we're going to look at this 9 arrow now, and I think we're going to have the same pattern show up that showed up before with the 6 arrows. So, can't be 1, 8, because there's an 8 in the box. Can't be 2, 7. That's the hard one to see. It can't be 2, 7, because it's looking at a 2, 7. And so if I filled in 2, 7 on this arrow, it all looks good until you realize that you've put 3 2, 7s in the row. So it's not 2, 7. It could be 3, 6. But it can't be 4, 5 because there's a 5 in the box. And again, we've gone through the version that involves a 1, a 2, a 3, and a 4. Alrighty. And so that's a 3, 6 now. So that is cool. So the 3, 6 here ends up looking at this 8, 6. Now we've got 1 arrow left. So could this arrow be 1, 7? It sure looks like it. Can it be 2, 6? It cannot, because there's a 6 in the box. Can it be 3, 5? It cannot, because there is a 3 in the box. So this is a 1, 7. Again, it's disambiguated by that, so that's a 1 and a 7. 1 and a 7. This 1 looks over, makes that a 4 and a 1. I noticed at some point that this 3 looks down here and gives me a 5 and a 3. Does really nothing look at these? Maybe nothing really looks at these. What are these 2 cells? They are a 2 and a something. 2, 3, 2 and a 4, it looks like. Okay, so that's sorted out by this 4. Makes that a 2 and a 4. The 2 looking over makes that a 7 and a 2. You can get rid of the coloring. And this 6 looks up and gives me the black and the 6. It looks up and gives me the 3 and the 6. And now Oh, I guess we do have an arrow left. Sorry, I thought we were done our arrows, but we're not yet done our arrows. We still have this mysterious 6 arrow that we have yet to fill in. But let's fill in all of our pairs. So these digits are a 2 and a 7. That doesn't. Oh no, 2 and 7. 2 and 7 sounds right. Oh, there's also an 8 arrow here. The arrows are multiplying while I'm not looking at them. These arrows are these cells are let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 and a 9. Okay, so let's examine the 8 arrow for what it could be. So again, could it be 1, 7? Again, the answer here is even more stealthily no, because there's a 1 and a 7 looking at. Yeah, I do not know where this 8 arrow came from. This 8 arrow and 6 arrow, I think Sven is working on this new feature where clues appear while the solver is not looking. So the software added this magic 8 arrow. Okay, so it is not a 1, 7. It's not a 2, 6, because there's a 2 and a 6 looking at it. And so that means the only thing it can be is a 3, 5. So that is a 3, 5. I think this 6 arrow is actually still undetermined. I can fill in the possibilities, but there's actually 2 of them. So could this 6 arrow be 1, 5? It can be, but only if this is the 1 and this is the 5. And could this 6 arrow be 2, 4? Yes, but only if that's the 2 and that's the 4. So we're going to have to do some Sudoku. We're going to have to Sudoku our way over here to figure out what's actually going on with this. These 2 cells seem suspicious to me, so let's go at them. So we've got 1, 2, 3, 4, 5, 6, 7. We need an 8, 9, and so that's the 9 and that's the 8. Now where does 8 go in box 5? It's ruled out by Sudoku from those cells. These aren't 8, so that's an 8. Let's see. I have 4 8s looking into this box, so I must know where 8 goes in this box. Yes, 8 in this box goes here. I'm being told that row 3 actually resolves the arrow. I will have a look at that later. What about these digits? These are a 3. Let's see, we've got a 4, we need a 5, we've got a 6, we need a 7, and then we've got an 8 and a 9, so these are 3, 5, 7. That's the 5. So this is not 5, this is not 5, this one's not 7 either, so this one is 3, and that one's 7. Alrighty, so these 2 digits, let's go ahead and fill in. What are they? They are a 2, and a 5. So we have that. This digit, I probably know what it is if I think really hard about it, because I've got all the other digits. So 1, 2, 3, 4, 5. I need a 6. So this is a 6. These digits are, let's see, I need a 1. I don't know where that goes yet. 2, 3. I need a 1 and a 3. So I'll write in 3 and 7 just for fun. I need a 1 and a 3. I don't know the order yet. Let's see. Here I've got 1, 2, 3, 4, 5, 6. I need a 7 and a 9. I don't know the order on that yet. What about... okay, so I want to look at this cell that people are telling me is resolved. If I look closer. I broke box 6. Oh no, what did I do in box 6? Uh-oh. How far do I have to rewind? Did I just fill in the wrong digits or what? Oh, I just made it so there's no place to put a 6 in box 6? Oh, it's because I filled in this pair incorrectly. That's, this 2, 5 is not actually a 2, 5. So this pair is actually a 5, 6. And that's not the 6. Because there's a 6 in there. Okay, thank you. So that's a 5 and a 6. So that 5 makes that a 3 and a 5. This row now is we've got 1, 2, we need a 3, 4, 5, 6, 7, 8, 9. This is a 3 and a 9, so that's a 3 and that's a 9. Let's see. What is left in... Yeah, what's left in this row? We've got 1, 2, 3. We need a 4. We've got a 5. We need a 6. Okay. So that's going to do it. So this 6 tells me that that's a 4 and that's a 6. And now that 4 looks up here and gives me a 1 and a 5 up there. And now the arrows are done. So now it's just Sudoku, although you've seen already how well just Sudoku goes around these parts. But we'll do our best to muddle through, as they say. These are a 1 and a 2, 3, 4, 5, 6, and a 7. This one's not 1, I see immediately. This one's not 7. This one inexplicably can be anything. Is this 2? This cell is the 2 or 7 for the column, but it's not a 2. So it is a 7. That's a 2. That's a 1. That's a 7. This row needs a 1, which has to go here. 2, 3, and then a 4, which goes there. This row needs a 2, which inexplicably is not resolved yet, and a 3, which mercifully is. So that gives us a 3 and a 2. That's the 2, that's the 5. So that 2 gives me a 7 and a 2. The 7 gives me a 9 and a 7. The 9 gives me a 4 and a 9. And now we need a 4 to finish this row, column, and box. Woohoo! Excellent. So we have successfully finished this, and so I think we're on good shape as far as these sorts of things go. So these were sort of the 1-star arrow puzzles. So we're going to move on to some sort of 2-star arrow puzzles. The stars is just sort of a rough proxy for difficulty. But you'll see what happens in the ones where we sort of jump up a degree is that usually there aren't any given digits. So we will we'll have a look at this. And so this is a puzzle by Playmaker that came recommended by a few people as a good arrow demonstration puzzle. And so going back to what I said about length 3 arrows, the sort of first thing you want to look at is everywhere you can see a length 3 arrow where none of the cells, or sorry, where all of the cells involved see each other, or where none of the cells can be repeats. And so everywhere I've highlighted in yellow, that is true. And so that makes all of these circles that match those arrows, those are all 6, 7, 8, 9. To make that work. And so now that has in fact actually given us a 6, 7, 8, 9 quadruple in row 3. And so we can fill in these remaining digits. These remaining digits are 2, 3, 4, 5. Okay. Now, I think now we have to talk about math. So when we talked about why a length 3 arrow is always at least 6, the thing we started with was saying, well, it's at least 1 plus 2 plus 3. What comes up in fancier arrow puzzles is that often you want to consider 2 arrows together. So in other words, if I sum all of these cells together, what do I get? And so what I really mean by that is I want to sum this whole arrow, that is all of the yellow cells, and this whole arrow, that is all of the blue cells. And I want to ask myself, what's the minimum value I could get out of that? And so notably, this given 1, I'm sure is here to make this digit a 2, but this is at least a 2. And so then the minimum I could do here for this sum would be this. Put a 2 here and make 1, 3, 4, 5 everywhere else. Putting the 2 here minimizes it because remember this cell is counted twice. And so the sum of these is 17 at minimum. Yellow plus blue is at least 17. But because these are arrows, the sum of yellow is this cell, and the sum of blue is this cell. And so what we're saying here is the sum of these 2 cells is at least 17. But there's only one way to get to at least 17, and that is to in fact get to exactly 17, with these 2 being an 8 and a 9. And in order for that to work, we needed this cell to be 2. If this cell was bigger than 2, if this cell was, say, a 3, instead of being a 2, the minimum would be add all of these together, 1, 2, 3, 4, 5, plus 3, that would be 18. You can't possibly get to 18 as a sum of 2 circles that see each other. So in fact, we actually get that this digit is 2, and these are a 1, 3, 4, 5 quad. Okay. Just to say that again, a little bit slower, just in case you're having trouble visualizing this. When I think about what the minimum value, the sum of these could be, is, I think about, okay, these are going to be 1, 2, 3, 4, 5 at minimum. That's 15. Plus, this cell's counted twice, so I have to add this digit in a second time to 15. So it is 15 plus, and this can't be a 1. So 15 plus 2 is the minimum. If it were 15 plus 2, 3, 4, 5, those all give me a number that's too big to be the sum of these 2 circles. So that is why this is a 2, and these end up being a 1, 3, 4, 5 triple. These being an 8, 9 pair means that these aren't 8 or 9. These are 6 and 7. I want to fill these cells in real quick, because I now know that these are a 6, 7, 8, 9 quadruple. And if you look over at the reference floating above my head, 6 and 7 arrows actually always have a 1 and a 2 on them. So I'm going to fill in that there's always a 1 and a 2. And so I think this is my first time today making these corner marks. The corner marks mean that within this box, I know the 1 is in one of the cells that's marked with a 1 in the corner. And within this box, the 2 is in one of the cells that's marked with a 2 in the corner. It's not that one, by the way. Same is true over here because of this. And ultimately, all of these digits I can also fill in. They're all from 1, 2, 3, 4. All right. Now we get to do the same trick a different way, which is to, instead of looking at the sum of these in the sort of complicated way, let's look at the sum of all the purple digits. What's the minimum value that the sum of all the purple digits could be? The minimum value is 15. Because again, this is a sum of 5 different digits, because they're all in the same column of a Sudoku. So there's these sum to at least 15. Now this digit's only at most 7. So in order to pick up the slack, this digit has to be an 8 or a 9. If I make this digit any less than 8, I'm never getting to a sum of at least 15, which I know I have to. And the same thing happens over here, where I can make exactly the same argument with the green cells. Take these 2 arrows together. Their sum has to be at least 15, and again, that means that this has to be an 8 or a 9. Now, that gives me an 8-9 pair down here, which is interesting, particularly as concerns 8 and 9 in this box. Because remember, 9 is never on an arrow. So actually, I know one of these digits is 9 now. And so that's ruling 9 out of this cell. Now, I'm sort of trained to be excited that I've removed a 9 from a circle, because normally when you remove a 9 from a circle, it is a sort of exciting moment because it means there has to be a 1 on the arrow. Except it doesn't do literally anything in this instance, because we already knew there was a 1 on the arrow, so that may have been a bit of a red herring. I'm seeing that these also can't be 2, And I'm seeing also that these are a 1, 2, 3, 4, 5 quintuple. So actually we can also fill 6, 7, 8, 9 into these cells. So we have that. All right. The arrows taken together trick can also be used sometimes when it's the same arrow. So normally when you have a 2-cell arrow and you ask, what is the minimum digit I could possibly put here? The answer is usually something boring. Like it could be, for example, it could be 3. If I have a 2-cell arrow, I could go 3, 1, 2. I can't actually do that when I have a double arrow like this. So if you think about it, actually the sum of the orange cells is double the circle value. And the sum of the orange cells is, by our sort of triangular number argument, it's at least 1 plus 2 plus 3 plus 4. It's at least 4. Sorry, it's at least 10. And so that means that this cell actually has to be at least half of 10. It has to be at least 5. So when you get this kind of arrangement, it actually gives you a lower bound here. Now, this 8-9 pair is actually doing something very interesting, though. Because this actually can't be 5, for the fascinating reason that if I make this 5, I can no longer put 8 and 9 in this box, right? The 8 is up here somewhere, as is the 9 is in one of these 2 cells. If I make this a 5, where are the 8 and 9 going? Well, the 9 can go here, but now one of them now the 8 has to go on an arrow with a -3. So actually, this can't be a 5, 6, or 7, actually, owing to this very clever 8-9 pair that's hanging out down here. So this is 8 or 9. Now, I'd love to say there has to be an 8 on this arrow with a 1, but I can't yet. But I do know that this is 8 or 9, at the very least. Alrighty, so what do I do now? Let's see. I don't even have something like a quad here. Let's see. Am I supposed to ask about this column? This column would be very exciting to look at. Yeah, so this column, what I'm noticing about this column is I probably can't put many high digits in here. And in particular, I can't actually put a high digit here either. That's a good point. Okay, so that's, I think, the point. So what's the highest digit I can put here? Well, I can't put an 8 here. So the highest digits I can put here are actually 7. I can't put a 1 because the 1 is already used up here. In fact, I can't even put a 7 here because the 2 is also used up here. So actually, these are from 3, 4, 5, 6. Okay, so that means all of these digits are at most 6. This digit's also at most 6 because it's on an arrow that adds to at most 7. So this digit is a 3, 4, 5, 6. And what that gives you, if you look closely, is the channel favorite a sextuple. Namely, because all of these digits, all 6 of them, are from 1, 2, 3, 4, 5, 6, that's the 1, 2, 3, 4, 5, 6 for the column. And so this digit can't be a 6. It's a 7. And this digit has to be an 8 or a 9. So that's awesome. And in particular, it's awesome because it has lots of fancy things. So it makes this a 6. That means that these are a 1, 2, 3 triple. These are a 1, 2, 4 triple. So there is no 4 down here. And I am noting actually now, if I look at this summing to 8 or 9, I have to use a 3 here. If I don't use the 3, what happens? Well, if I don't use the 3, then I'm adding 5 and 6, which do not add up to 8 or 9. So I have to use a 3 here. And now I'm noting that because this digit can no longer be a 3 or a 4. The 4 is here. And so this 5 or 6 matches with those 5 or 6s. We're adding to 7 here, so this digit is a 1 or a 2. I can now look over on the column 9 side and ask myself, how is this arrow ever going to work? And there's a few different ways to see that. One of them is to remember I needed these to add up to at least 15. And well, if this is an 8, that's not going to work. The other is to ask, what is the absolute minimum I could put on these two cells? 1, 2, and 3 in the column are gone, so the absolute minimum I could put is 4 and 5. But that's also the maximum, because this is at most 9. And so then that makes that an 8. Makes this a 3, 5 pair, which now comes up and makes that a 6 and a 1. So things are progressing, as we hope. Or as we would hope. So this is a 1 up here. So this is at least 5. Do I even feel like pencil marking that? I don't really want to. This 6 at least sees this circle. So this circle is now a 7 or an 8. What does that do? Okay, so the 6 in this box is in one of these two cells, because I can just do Sudoku on 6s and ask about that. But I don't see that right away. Oh, this 8 does Sudoku this 8, 9 into a 9. There we go, there we go, there we go. The 9 here then makes that an 8 and that a 9. So I now need to make these add to 8, so I need to make these add to 6. And I can't make these add to 6 without a 1. And so it's 1 and 5. And so these aren't 1 and 5. These are 3 and 4. So this digit's not a 5. This digit's not a 3 or a 4. Okay, so if this is an 8 arrow now, it can't be a 1, 2, 5 arrow. If this is an 8 arrow, it's now got to be a 1, 3, 4 arrow. Which means there's always a 4 on this arrow. Okay, so here's a way to play commonalities. By again looking at the little cheat sheet if you don't have all of these worked out. If this is a 7, this has to be 1, 2, 4. If this is an 8, it can't be a 1, 2, 5 because it would make this have no value. So it's a 1, 3, 4, which means there's always a 4 on this arrow, and it doesn't go in the column with a 3, 4 pair. So in fact, that's a 4. In fact, actually, smarter way for Zeta to see this 3, 4 pair tells me this digit can be neither a 3 nor a 4. So this can't be an 8 arrow anymore, because if this were an 8 arrow, we said it would have to be 1, 3, 4, but this could be neither. So in fact, this is a 7, that's a 2, that's a 5. This isn't a 2 anymore. And so we're moving right along. In fact, this 4 gives me a 3 down here as well. These are not 3 or 5. These digits are 2, 3, 4, 5. These aren't 2 at the very least. These digits are 1, 2, 3, 4, 5. We need a 6, 8, and 9. This one's not a 6 at the very least. And I know from my magic 9 down here, pencil mark down here, that that's not a 9. And actually, here's a good thing. This 7 removes 7 as a candidate, and now I actually have a 6, 8 pair. And so the 6, 8 pair in this column means this isn't an 8, it's a 9. So now I know what these two digits are. These two digits are a 2, 3, and a 4. And so that's actually funny because it tells me what this quad is. Because, again, remember from before, there are 4 ways to make 9. There's 1, 8, 2, 7, 3, 6, and 4, 5. Well, I can't use 2, 7 because the 2 in the box is over here. I can't use 4, 5 because the 4, 5 in the box, or sorry, because the 4 in the box is over here. So I have to use 1, 8, and 3, 6. So here are my 1, 8, and 3, 6. And I can allow myself the luxury of doing some Sudoku, like the 1's not here. And since the 1 goes with the 8's not here. The 3, 4 tells me the 3's not here, so the 6 isn't there. And so I get this 3, 8 pair here, looking up now at this cell, so that cell's now the 9. This isn't a 9. And I now have a 1, 6 pair looking up at this cell, which means that this is an 8 and that's a 6. That 6 chases down to here, means that's an 8. Means none of these are 8. This one's not 6 either, owing to the 1, 6 pair, while we are cleaning up. This column needs a 7 and a 9. Well, for lots of reasons, this cell can't be the 9. So this cell is the 7, and that cell's the 9. So these aren't 9. This digit is now a gimme, because we've got everything else gone. So it's not 1, 2, 3, 4, it's a 5. We've got that. Okay. I'm looking at where 1 goes in this box, and I'm noticing that the 1 in this box has to go in one of these 2 cells, but I'm not seeing anything interesting about that yet. So instead I'm going to fill in these cells. So these cells by the column are a 7 and an 8, and we know the order. So that's the 8, that's the 7. Let's see. Okay. What about the row? Let's look at the row. We might be able to force one of these arrows. So we've got a 1 here in the row, or we still need a 1. We've got a 2. We need a 3, 4, 5, and we got 6, 7, 8, 9. Okay, so this is a 1, 3, 4, or 5. What is this cell? So it can't be a 3 because there's a 3 in the box. It can't be a 4 because the only way to make 4 is 1, 3, and for lots of reasons I can't make this 1, 3. So this is at least a 5. Unfortunately, I don't yet see much reason why it can't be basically any of those things. So that's dismaying. I think the same thing is true over here, actually. The minimum this can be is a 5, but I don't see why it can't be anything. Let's see. Let's continue Sudoku. Sudoku's often the answer. This can't be an 8. This can't be a 9. Let's see. Alrighty. This arrow I realize I have not looked at all yet. So what's the minimum value that this arrow can take? So this could be a 1. This could be a 3. So that would be 4. And then this could be a 1 as well. Because remember, this is a length 3 arrow. I should have pointed this out at the very beginning. This is a length 3 arrow, but they don't all see each other. So all of the sort of the strength, the wind goes out of the sails of what this could be. And so 1, 3, 1. I mean, this is at least 5. So this is 5, 6, or 7. I am learning. I see things like, I'm not keen to use it, but I see things like the 3's align in these 2 boxes. So if I ask where 3 goes in row 9, it can't go in any of these cells because this box already has a 3. It can't go in any of these cells because this box already has a 3. So one of these 2 is a 3, but I don't even think it helps yet. As we have so far seen. What about this row? Maybe I should think about this row, because I realize I have not even filled in that this is 2, 3, 5 yet. Does that do me any good? Not that I see. It might do. Let's see. Okay. Let's see. So we've got some 5s and some 5s. Okay, so we can ask questions like, where does this arrow go in box 4? And so this is often a good idea to ask is, okay, I should let's give this a color, orange. You can ask, where does orange go in box 4? And so orange is a 5, 6, or 7, so it's not in any of those cells. Orange is not in the same column as orange. But orange also can't go here because this is an arrow that adds to orange. And so the way you'll often hear this is the circle of an arrow will never repeat on the arrow itself. So I know that one of these two cells is orange. I don't know which, but I'm going to mark it that way. And the reason I'm going to mark it that way is that now where does orange go in box 1? It goes in one of these cells. And so the key here for going in one of these cells is these cells are a 9, a 6, and a 7. And so if these cells are a 9, a 6, and a 7, this can't be a 5, because then we'd need to put a 5 here, and we can't. So this cell is only a 6 or a 7, actually. So that's very interesting. Okay, so maybe I should ask, what's the maximum value this cell could be? These could both be 1. And so this cell is at most a 5, is the point. This cell here is at most 5 because these sum to at least 2, and this is a 6 or 7. So this is a 1, 2, 3, 4, 5, but it's not a 1, 2, or a 4 because those are already gone in the box. So, in fact, this digit is a 3 or a 5. Let's see. So what is that going to do for us? Anything exciting? Okay. I'm going to steal something from chat, which is very nice, which is, where does 8 go in this box? 8 in this box is pushed into exactly the same spots. So these two cells are orange and 8. So in particular, this cell's not 5 either. And neither of them is 9, because one of them is orange and one of them is 8. So these are from 6, 7, 8. That's helpful, I think. So, let's ask ourselves the simplest question in the world. Where does 9 go in this box? 9 in this box can't be in any of these cells, and it can't go in an arrow that adds to 6 or 7. So 9 is here. Let's see. Interesting. Okay. Now, I should actually, now that I've done a lot of work on this arrow, I should actually look at this and see if there's anything I can rule out. Like, for example, this digit can't actually be 8 anymore, because I can't add to 8 anyway. Despite the fact that 4 and 4 are marked, I can't make this arrow 4 plus 4. So the Sudoku stuff has sort of whittled this away to the point where this can't be 8 anymore. So Remembering that this is an orange 8 pair, actually, this is the 8. This is the orange. Let's see. Okay. Does that do anything? Okay, this 8 over here. So that. No, never mind. I am seeing there was sort of an alternate path to see that this couldn't be 8 by seeing that we'd ruled 3 and 5 off, or we'd ruled 3, 5 pair off of it, but that's fine. We've got a 6, 7 pair in this row, so this is not 6 or 7. Let's see. This digit is at most a 3. That's another thing I should fill in. So the minimum these sum to is 4. So this is at most a 3. So this is only a 1 or a 2 because it can't actually be a 3 because there's a 3 in the box already. Just sort of working my way up to trying to find a triple or something in the row. Chat has noted for me that there is a 1, 3, 4 triple and a 6, 7, 9 triple in row 5. So actually, this can't be a 1. So that's a 5 and a 1. That's nice. So these aren't 1. So these are now a 2, 3, 4 triple. Oops, sorry. These are a 2, 3, 4 triple, so we can fill in the rest of this. So we've got a 2, 3, 4 triple and a 6, 7 pair. So that means the rest of this row is 5, 8, and 9. This can't be 8. This can't be 9. I do know one of these two is a 9. I don't know which one yet. Oh, I have the same problem with this cell over here. This cell can't be an 8 either, because it can't be 4 plus 4 because of Sudoku, and it can't be 2 plus 6 because of the 6 in the box. So this actually can't be 8, which does give us a 5, 9 pair here, making this the 8. And once this is a 5, 9 pair, I see that this digit's always odd. This digit's always even, so this digit's always going to be odd. So it's never a 4. Sorry, it's never a 4. Is what I meant to do there. Is to take away the option of this to be 4. One of those two is the 4. Not yet exciting. Let's see, and I don't know anything nice like there's always a 3 on here or anything, right? No, I do not. Alrighty, we're slowly whittling this down. The intro of this puzzle was super easy. Was super smooth and clear. This part I'm a little more lost. I'm a little more looking for things. Where does 9 go in this box? There we go. No, 9 in this box has, I guess, 2 places. It could go in one of those 2 places. Let's see. We can look at, like, this intersection. I'm betting this has to be a 1. Let's try the opposite end. Let's try making it a 4. Is it possible that this is a 4? No, because if this is a 4, immediately those two sum to at least 7, and then I need to add that digit. So this can't be a 4. Oops. Can't be a 4. So this is a 1 or 2. Can this be a 2? If this is a 2, so you could go 2, 3, 2, and that would be okay. Or 2, 3, 1, actually, would also be okay, I think. I know this digit goes on this arrow, but of course it goes on that arrow. Let's see. Let's see. So let's see. What happens if this? I'm just eyeballing some things chat is suggesting. But I don't quite see anything yet. Let's see. Yeah, we've got almost all our low digits in row 7, but not quite all of our low digits in row 7, unfortunately. Oh, there we go. Where's... No, not quite. Darn. We almost know where 5 is in this row, but not quite. 5 in this row is in one of those slots, but I don't know which one yet. Let's see. Where is 3 in this box? That'll at least get me 1 elimination. I don't know if it'll do me any good yet, but one of these 2 cells has to be a 3. Because of this box not having anywhere else for 3. So one of these 2 is a 3, so this isn't a 3. That's at least something. That is a 1-2 pair. Let's see. Okay, I think I'm going to fill out this row. I may or may not immediately regret this, but I'm going to fill out this row and see if I regret it. So they're not 1, 2. They could be 3, 4, 5, 6, 7, and they're not 8 or 9. But let's clean that up, because this can't be a 4, because there's a 4 in the box. These can't be 3, because there's a 3 looking at it from over there. Okay, I regret it. I have regrets. Okay, I guess I can do Sudoku on orange. Maybe I'm supposed to do Sudoku on orange, because I'm realizing this is not orange. Or sorry, this digit is the 6, 7 that's not orange. So this is the 6, 7 that is orange. But I don't think that super helps either. Let's see. I'm trying not to use the chainier spots that chat has. I'd use them normally, but I'm trying to do this one in the sort of the cleanest way possible. Let's see. So I'm trying to stick to things. Let's fill these in. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are from those digits. These aren't 7. These aren't 1. Let's see. Someone's mentioning something about the box 8 arrow. I'm not quite sure. Okay, good point. Okay, we did get a quad in column 2. We have a 2, 4, 6, 7 quad here. So at least this isn't a 4. This is a 3 or a 5. Aha! And that'll do it. That's it. That's the point. This 2, 4, 6, 7 quad got rid of a 4 here. And now this is always an odd plus an even. And then an odd plus an even is always odd. So orange is 7. So that digit's a 6. And I bet that will make our lives easier. So these aren't 7. Sorry, I guess that one's not 7. I need a 7 over here. Okay, so this could be a 3 with a 2 plus a 2, or a 5 with a 1 plus a 1. And that doesn't immediately give it to me. one of these is the 6 for the column. So let's get the 7s out of here. One of these is the 6 for the column, so this isn't a 6. Let's see. There's a 7 over here somewhere. Let's see. Okay, what else can we do? Let's see. We've got I had thought that realizing that this was a 7 was going to sort of resolve life for us, but it has not yet resolved life for me. So these two cells also add to 7, I guess, is one of the points. These are either 3, 4, or 2, 5, because this is the other one. I feel like I'm trying to make this a 2-star puzzle, and I feel like the row 7 thing is beyond a 2-star puzzle. Maybe not, but I'm trying to keep this as intro friendly as possible. Let's see. But I may give up and use it. We'll see. So is there some combination here that obviously doesn't work for some reason? Let's see. Row 3, column 8. Too many 2, 3, 5s in column 8. Let's see. So if this is a 2, this is a 3 or a 5. Okay, so this is a little messy, but we can do this. If this is a 2, it does not work with this combination of cells. Because if this is a 2, how is this working? The only way, or I guess maybe actually, I think the easier place for me to see it is to start here. Can this be a 5 with a 2 and a 3? And it can't be a 5 with a 2 and a 3 because that would be that cell. And that would give me 4 of those. So even if this is a 5, it's a 1 plus 4 kind of 5. But the 9 here can never have a 2 with it. So this is always a 4. And that's a 2, which makes that a 5. These are, of course, now not 5. That one's now a 3 and a 4. This is now not a 3. It's a 1 or a 5, but it's not a 5 either, because there's a 5 looking at it. So that's a 1 and that's a 5. Let's see. So this is not a 1 or a 4. Actually, this is just resolved by the row. This is a 3. This is not a 3 or a 5, so it's a 2. That's the 5. This is not a 4 or a 5 now. This is a 6 or a 7. It's not a 7, though, so it's a 6. That's the 7. That's the 9. Let's see. This is not 5, 6, or 7, so it's a 4. Let's see. That 3 means this 3 is actually here. We've got 1, 2, 3, 4, 5, 6. We've got 7 and 8 left to place. That's a 7. That's an 8. This column needs a 1, needs a 1, a 2. We've got a 3, 4, 5. We need a 6. So that gives us a 1, 2, 6 triple in the row. And so if we've got a 1, 2, 6 triple in the row, that means this can't be a 2, so it's a 4, which makes that a 5 and a 4. This 4 looks over here at least and sees that that's not a 4. We've also got our 1, 2, 6 triple here. Not sure that one's being quite as profitable for us. Oh, however this 8 is. So that's a 3, and that's an 8. That 3 makes that a 6, and that a 1. That 6 means this isn't a 6. This isn't a 1. This is a 2 or a 6. Let's see. That 3 means this is a 5 and a 3. Let's see. I've still got a 1-2 pair. This isn't a 6, though, so let's nip that in the bud. So these are a 3-5 pair, which makes that a 9 and a 6. Let's see. Box 8 is now pretty done. So these aren't 2. This 5 looks down and makes that a 3. Makes that a 5. Oops, makes that a 5. Now that this is a 3, I need these 2 to add to 4, and the only way to do that is double 2. So 1, 6, 2, 6, 4, 1. 2 makes that a 4 and a 1. 4 makes that a 3 and a 4. 3 makes that a 2 and a 1 and a 3. Very nice. And so this puzzle, by the way, is the sort of the first in a long line of Playmaker Arrow puzzles. We'll be doing another later as the most voted on. But I've done many of the Playmaker Arrow puzzles. This is quite a cool puzzle. I really liked this, and it really did an excellent job at sort of showcasing all of this stuff at the beginning with the what does it look like when you're batching multiple arrows together? Because the batching multiple arrows together is a technique that shows up a lot. Okay. So, by the way, I did want to say what chat was talking about during this, because there's another thing that you often want to do in arrow puzzles, but that I thought was probably a little beyond where we're going for this puzzle. But chat was noticing to think about in this row where you need to put your high digit. So you needed to put 3, 6, 7, 8s. And if you actually thought about it from that point of view, then it was clear that you could make some eliminations based on that, because a few of the combinations for these arrows would have put too many low digits into this row. That's a sort of a more advanced technique, but one that is very useful in a lot of arrow puzzles, because arrows like to have big digits in the circles and little digits on the arrow. All right, I want to do one more arrow puzzle before we call the tutorial done, and then go back and do more arrow puzzles. And the one more puzzle I want to do is this puzzle, Somersaults, by Derektionary. So we have one more of these to look at. And so this features some length 5 arrows. And so your brain should immediately be sus about any length 5 arrows that you see. And so let's just think, how am I ever going to make this circle a single digit number? And so what's the minimum I could possibly do? Well, I could put a 1 and a 2 here and a 1, 2, 3 here. Well, that's already 9. So this digit does have to be a 9. These digits have to be a 1, 2 pair, and these have to be a 1, 2, 3 triple. That's the only way this is going to work. And so when you have arrows that cross boxes, this is a pretty common combination, is that you'll have an arrow that crosses a box, but 3 of the cells on that arrow are already in one box. Then you sort of know the things that dangle out of the box. In that case, these have to be very small. In this case, they have to be, in fact, exactly a 1, 2 pair. I want to mark that the same thing happens here. And then I want to notice that that's put a lot of pressure on these cells. Because now, if I look at these cells closely, this one's at least a 4, and this one's at least a 3. So actually, this arrow can only sum to 7 or 8. And it has no 1s or 2s on it. And so what is this arrow going to be? Well, the key thing is it can't have a 1 or 2 on it at all. So it's at least 3 plus 4. And so it can only be 3 plus 4 or 3 plus 5. Those are the only ways I'm getting to 7 or 8. And in particular, there's always a 3 on it. And so this digit is not a 3, which gets us a 1-2 pair in the column as well. And we get to do the same trick, or a very similar trick anyway, in this row, because the 1-2 pair look at this arrow. And if the 1-2 pair... Sorry, I just noticed something. This is a 1-2-3 triple looking at this cell. So that's the one that's the 4 or the 5, not the 3. This is the one that is the 3. So we get an actual digit. I'll look at this arrow in a second, but now this arrow is even better than it was a second ago. Because now this arrow has 2 cells on it that each can't be 3 or 1 or 2, because there's now a 1-2-3 triple looking at both of these. So these are each at least 4 or 5. But the only way it works out for this cell, because this cell can't be 9, if I add 2 digits that are each at least 4 or 5, the minimum I get is an 8, and the only way I get an 8 is if both of these are 4. And so I actually get 2 4s here. That 4 comes over here, tells me that's a 5 and that's an 8. So that's gorgeous. And so we've got good things going on here. And so again, we have here repeat digits on arrows. Those are perfectly allowed and in fact often encouraged. And I'm seeing that now this digit and this digit are in the same position. Namely, they can't be 1, 2, 3. This one can't be 4 either. So this one's at least 4, this one's at least 5. So this can only be 9 with a 5 and a 4 in that direction. So we've got that going on down there. And we might as well fill in, what are these? These are a 6, 7, 8. And that one's not an 8, it's a 6 or a 7. These digits are a 3 or 5, 6, 7, just for posterity. These digits are, let's see, we've got 1, 2, 3, 4, 5. These are 6, 7, and 9. Okay. Let's go back now and consider this digit, or these digits. They're a minimum of 3 and 4. So this is a minimum of 7. So this is 7, 8, or 9. This one, let's see, this cell, oh, actually, yeah, both of these are big. Okay. This arrow is also restricted because neither of these, this cell, this is very clever. This cell sees that 1, 2, 3 triple. This cell sees that 1, 2, 3 triple. So these are in fact a minimum of 4, 5, but they're also a maximum of 4, 5. So that's a 9 as well, which is cool. So this isn't a 9 anymore. So this is a 7 or an 8, which means that this arrow is from, as before, 3, 4, 5. If I try and put any digits bigger than 5 on this, I'm immediately going to bust. And I need to put a 3 here, which then, in fact, gives me this 3, 4, 5 triple in the row. So we've got 1, 2, 3, 4, 5. We need 6, 7, 8 for the row. However, there's a 6, 7, 9 triple in this box already. So this is not 6 or 7. It is, in fact, 8. So these two are not 8. They are 6, 7. Let's see. What are the... Oh, sorry, no. What are the... Oh, I guess I don't quite know yet exactly how this resolves. Okay, but I suppose I should probably be continuing to look at where these remaining digits are going. Okay, so what's left in this column that can possibly go here? Let's see. 1, 2, 3 we don't have yet. We've got 4, 5. I can't put... Actually, maybe I could put a 6 or a 7 on here. Maybe, possibly. Oh, I have to have a 6 or a 7. Okay, got it. Okay, so... and this is not 8 or 9. Okay. So let's do the thing that people were very excited about last time. Where are the 6s and 7s in this column? Well, let's just start by highlighting only the cells that can be 6 or 7. It's these. Well, can these both be 6, 7? Well, no. Because then this arrow would sum to at least 13. I'd need several negative numbers on it. So this cell can't be 3. That's the first consequence of this. One of these is a 6 or a 7. And so if I'm putting a 6 or a 7 on this arrow, that means this cell can only be an 8 or a 9. And this is at least 7 in total. Because it's at least a 6 plus a 1. And so this digit can only be a 1 or a 2 in order to make this an 8 or a 9. Oh, spoiler, by the way, it's not an 8, actually. It is a 9, unfortunately, but it is what it is. But you can do a similar trick over here. What are these? Well, these are at least 3 and 4. So this digit can only be a 1 or a 2, except these digits being at least 3, 4, plus 1 means this digit's at least an 8, and it can't be a 9, so it is an 8. And that's a 1, and these are 3, 4. And so this is a 2. And so I need these to add to 7, so they're not 2 or 3 or 7. They are 1 and 6. And so that's going to Sudoku lots of things. 1, 6 makes a 7 down there, makes a 2 there, a 3 there. No 3 there. That 2 makes this a 1 and a 2 and a 1. These aren't 7 anymore. That 1 makes this a 6 and a 1. That 3, 4 makes this a 1, 2 pair. Let's see. We've probably got more Sudoku if I look closely. One of these is an 8. This is a 9 because of where 9 goes in this box. Can only go there. Let's see. What is left up here? We've got a 5, 6, 7, 8 is what's left to go in this box. These aren't 8. These aren't 6. These aren't 5 because of the 4, 5 pair in the column. That's suspiciously close to useful, actually. I don't think it's quite there, but it's getting there. Let's see. Okay, let's pencil mark the rest of this box. That'll probably be useful. 1, 2, 3, 4, 5, 6, 7. These aren't 3. That does do something immediately, which is to put 3 in one of these two cells, which looks at this cell. Which means that this is the 3 for here. I did not pencil mark that goodly. Someone is pointing out. Let's see. These are 3, 4, 5, 3, 6. 3, 6 is probably better. Yes. And so that's the 3 and that's the 6. These aren't 6. That's the 6. That's much better. These two cells are a 4 and a something. 4 and a 9. So it goes that way. 9, 4. The 4 looks over, goes 3 and 4. This 3 now is placed there, so this isn't a 3 anymore, or in the corner for that matter. This is a 5 or a 7, can't be an 8. Let's see, what's left in this box? We need a 2, and a 5 and a 7, I'm guessing? Yeah, 2, 5, 7. Sounds fair. This one's not the 2 either, though, because there's a 1, 2 pair looking at it, which means that this digit is a 2. Let's see. We've got our 5, 6, 7 looking like that. Here's another observation. The 6 in this row is here in one of these two cells. So this isn't a 6. Amusingly, I think this was listed as a 3-star puzzle and Playmakers was listed as a 2-star puzzle, but I agree that to my sensibilities, this seems much easier, but what are you going to do? Maybe you're just that much better at arrow puzzles now, having listened to the beginning of the stream. So this is a 6 or a 7. Let's see. These digits, 2, 3, 4, 5, 6, 7, 8. This is not 4 or 8. This is not 8. That was probably not the smart thing to fill in. Let's see. Let's see. Row 5. I'm being told that this cell is a naked single, which is gorgeous. Okay. So this is not a 1, 2, 3, 4, or 5, or 6, 7, or 9. So this cell actually can only be an 8. That's gorgeous. Great spot to the chatter who spotted that. This is the other 4 or 5 for the box. That 8 looks up and gives me a 7 and a 6, and a 5 and an 8. That 7 comes down here, gives me a 5 and a 7 over there, gives me a 7 there. Tells me that those are 5 or 6. Let's see. So let's fill in these cells. So I need a 1 and a 2. Got a 3. I need a 4 and a 5. Then I've got a 6, 7, 8, 9. This is not 2 or 4. This might be able to be anything. This one's not 1, though. I admit that's disappointing. Let's see. That's where the other 4, 5 is. Yeah, where does 4 go? Okay, so here's a good question. Where does 4 go in this box? 4 in this box is ruled out of these cells, and 4 also can't go in this cell, because that would make this a 4-5 pair. That would make this arrow a 4-5 arrow, and it can't be. So 4 is in one of these two cells. Similarly, 5 is actually, I guess, pushed into... Can't be there. 5 is also pushed into 2 places. It's not as useful as I was hoping. Never mind. I thought that was going to be really sweet. Did not end up quite that way. But there's a much, much, much easier way, which is that this 5 looks and sees that 4, and that 5, and that 4. So that's not a 4, but now that's a 5 by our previous work. That's a 4. 3 plus 4, and so this is, I will say, this is like the thing I most often miss in arrow puzzles, is that I've now filled in this complete arrow, so I should remember that this is a 7. So it's a 6 and a 7. Let's see. So this arrow can't be 1, 8. It can't be 2, 7. It can't be 1, 8 because there's 2 8s looking at it. It can't be 2, 7 because there's 2 7s looking at it. It can't be 4, 5 because there's a 4, 5 looking at this cell, and a 4 and a 5 in the box. So this can only be 3, 6, and we know the order. 3 and 6. So now that cell's not a 3, which gives us a 3 there. Means this is a 1 or a 2. This is a 1 or a 2 for the column. This is whatever's left over. 1, 2, 3, 4, 5, 6, 7. This is an 8. Which means that's a 7 and an 8. These aren't 7 anymore. Let's see. Yeah, this is a gorgeous puzzle. I really like this one. We got 1, 2, 3, 4, 5, 6, 7, 8, or 9. I think I did that right. This isn't a 2 or a 4. This isn't a 1. These are 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 1, 7. It's not a 3 either. These aren't 4 while I'm at it. Let's see. Does that do something? This isn't 4 either. There we go. This isn't 4 either. So where does 4 go in this box? Only there. There's a 5, 6 pair in this column. So this isn't a 5 or a 4, so it's a 2. So this is not a 2 or a 3, it's a 7. So that's just a 5, 6 pair. This isn't a 7. There's a 1, 2 pair here, which means that's the 3. We've got a 1, 2, 9 triple. This isn't a 4 anymore, I can point out. Let's see. This 7 looks up and says that's not a 7. The 5-6 pair also looks at this and makes that a 9. Means this isn't a 9. This is a 6 or a 7. There's a 5-6 pair in this box, which makes this an 8. Is that the last 8? That is the last 8. That 7 looks down and makes that a 6, and a 7, and a 5, and a 6, and a 5, and a 6. We will, by the way, to those of you joking about how we could color stuff, which I am always happy to color stuff. I will eventually do a tutorial on things like simple coloring. So if you want to do a more abstract intro puzzle for me to use at a later point, something like an intro coloring puzzle or simple coloring puzzle would be very welcome. Alrighty, and that is this puzzle. So I think that gives you a bunch of the cool things that show up in arrows. Now, as sort of a concluding remark, I want to note that there are tons and tons of tricks that come up in arrows. Coloring comes up in arrows. Often arrows mean you end up doing a system of equations of some sort. Actually, if you want to look, just last stream, I did a cool Naverio arrow puzzle that involved a system of equations. There's a lot of variety in arrow puzzles. And so I'm going to end the tutorial here, but we are going to do a lot more arrow puzzles today. So there'll be a link in the description if you want to go back and look at some more arrow puzzles that we've done, because really it is a very rich genre.